Hello friends, now we have a clear idea about Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Now we'll study a differential length, area and volume in these particular coordinate systems that will be helpful to solve various problems in electromagnetic engineering. First of all, we draw a Cartesian coordinate system that can be represented in this is x-axis, this is y-axis and this is z-axis. Now the limit of y is infinity, here minus infinity, x is infinity and here minus infinity, and z is infinity and downwards minus infinity. If we take a section of y, that is called as a dy, differential length. This is called as a dx and this will be called as a dz. Now from the diagram it is very clear that a section of particular line, okay, our derivative of particular line is called as a differential length. Okay. The dl can be written in vector form is equal to dl bar is equal to dx ax plus dy ay plus dz az. Now we know the formula for surface. Okay, and normal dl is equal to what? Dx comma dy comma dz, whatever it may be. Okay. Now what will be the formula of surface? We know surface is what? Multiplication of two length. अगर मैं बात करूँ differential surface, if I am talking about differential surface, that will be integral, double integral of two lengths, that may be dx dy or dy dz or d dx dy dz or dx dz. So this will be surface 1, surface 2 and this will be surface 3. Or area, we can say area. And what will be the volume? Volume is triple integral of dx dy dz. In this ds1 with limits x and y, we have y and z and x and z. If I find out the vector of ds1, ds2 and ds3, we have to multiply the unit vector which is constant. For this particular surface, x and y are variable, so z is constant, so we have to multiply with unit vector of az. In this, y and z is variable, so ax is the unit vector, and in this x and z are variable, so ay is the unit vector. So this is the differential length, differential surface and differential volume in Cartesian coordinate system. Now we'll find out the differential length, area and volume in cylindrical coordinate system. For this particular calculation, we have to first draw the Cartesian coordinate system. The Cartesian coordinate system is base of all coordinate system, and then we have to draw a circle with origin as a center, and this particular circle is the base of our cylindrical coordinate system, and we have to draw a parallel line to that particular circle, and again we have to draw the upper circle of this cylinder with center as z-axis. Now take particular point P and connect this point P with origin O. Also its point P dash on the upper circle. This angle is horizontal angle phi, and this is the line OP, or we can say O dash P dash is nothing but a radius. Now if we draw the base circle like this, the center O, this is Y and this is X axis. This is point P. So this vector is unit vector AR, because this OP is nothing but R. This angle is angle phi. So this is the direction of phi. So this is unit vector A phi, and Z is upward. That means AZ is coming from paper towards the camera. In this case, if we consider this particular circle where R is constant, if we consider on this particular line OP, my constant is phi, and this whole circle Z is equal to 0, means Z is constant for this particular circle. Now if I take a section of the radius R, or section of OP, this particular section is called as differential length, and that is nothing but dr. Okay, or differential length in the radial direction, it is called as dr. So we get the first differential length. Now we have to find out the second and third differential length. For the particular calculation, what we do, we draw a diagram. Again we have to draw a Cartesian coordinate system. This is Z, this is Y, and this is X. Okay. Now draw a point P. Project that particular point P on XY plane. P dash, here is P. Connect P to O. Now move this point P on the surface of cylinder. Okay. Connect this point. This point is Q and this point is Q dash. The angle, this is phi. So we can say this is d phi. Now we have to find out this particular length, or we can say PQ. Find out length PQ. But as shown in the diagram, PQ is not a straight line, it is arc. or a part of circumference of the circle. So what is the formula for this thing? The formula for arc is radius into angle. So PQ, arc PQ is equal to, radius is what? Radius R into angle d phi. So PQ is equal to R d phi. This we got this. We got the first differential length dr. We got the second differential length r d phi, and now the third differential length in spherical cylindrical coordinate system. And now the third differential length in cylindrical coordinate system is vertical thing, say dz. So we get dr comma r d phi comma dz. So this is differential length in spherical cylindrical coordinate system. So this is differential length in, so this is differential length in, so this is differential, so this is differential length in cylindrical coordinate system. So this is differential lengths in cylindrical coordinate system. Now calculate for differential surface, surface 1, surface 2 and surface 3. We can easily calculate the integral of, double integral of dr into r d phi, where z is constant. Second, double integration of dr into dz, where phi is constant. And third, r d phi dz, where r is equal to constant. Similarly, volume is equal to triple integral of r dr d phi dz. Now we'll calculate the differential length, area and volume in spherical coordinate system. As shown in the diagram, point P is placed in spherical coordinate system, that is r, theta, phi. Now here in this particular diagram, we know three variables. First one is radius. Radius is nothing but distance from origin to point P. Second is phi, horizontal angle, and third is theta, vertical angle. So first dimension is radius, so we can easily say the differential length is nothing but dr. Now we have to calculate the two differential length. First is dr in terms of radius r. Second, we have to find out in terms of phi, and third we have to find out in terms of theta. So for this particular calculation, we have to redraw this diagram and represent the differential lengths. Now say this particular point P is placed in this spherical coordinate system. Now what we have to do, we have to change the angle phi. Now what is the meaning of changing angle phi? This particular point P dash is moved to P double dash. The angle will become d phi. The small variation in angle will become d phi. So again connect this point to the z axis. So this point P will move to this particular section, say name it as A. So say this is point A. Again see, PA is a curve or PA is an arc. Now what we have to do, we have to change a slight in theta. So this is theta. Now move this particular point P to point B and again connect this. So this is d theta. So now this will be d theta. Now if I connect these surfaces, it will be the like diagram this. Now again we should understand the arc PA is result of variation in phi. So this will be variation in phi and this will be the variation in theta. Now we have to find out the arc PA and arc PB. So this will be the differential length in phi and theta direction. Now see, for the calculation we have to connect this point P to z axis by perpendicular. We calculated this particular is r sine theta. Okay. This will help you. This will help us to find out the values. Now for this particular point P, this will be the radius. So radius is r sine theta and the angle is what? d phi. So arc PA for arc formula is what? Angle into radius. So PA is what is angle? D phi. Radius is what? R sine theta. So PA is equal to R sine theta d phi. So we got for phi, differential length for phi is r sine theta d phi. Now what we have to calculate? We have to calculate for AB. Now arc AB is equal to angle into radius. Okay. Now this is with respect to theta, that means the radius is r. Okay, radius is r from the origin, not from the z axis. This is in terms of phi. Phi is moving as a center taking z axis. Okay, for phi the variation for phi the variation is along z axis. Z axis as a center. So if I move this point to this, so radius will be r sine theta, not this r. But theta is moving from this. For theta we are taking origin as a center. Okay, so radius is r and angle is d theta into r. So for AB, r d theta. So we can say r d theta. So we get differential length in spherical coordinate system. So what will be the differential surface? ds1, ds2, ds3, that is equal to dr into r sine theta d phi, that is equal to r dr sine theta d phi, where theta is constant. ds2 is r dr d theta, where phi is constant, and ds3 is what? r square sine theta d phi, where r constant. The volume is equal to, what we have to do, we have to double integrate here and here also, and for volume we have to triple integral and multiply all this thing. R square sine theta, r square sine theta d theta dr d theta d phi. So this is the differential length, volume and surface for spherical coordinate system. I hope you understand.